announcing the arrival of Yang Berbahagia Profesor Datuk Teknologis Dr. Wahid bin Razali, Vice Chancellor of University Tun Hussein on Malaysia, accompanied by Yang Berbahagia Deputy Vice Chancellor Academic and International, Professor Dr. Ismail bin Abdul Rahman, Professor Teknologis Dr. Badrul bin Omar, Keynote Speaker for the first Lecture Series 2020. Lagu Bangsa Johor dan Negaraku. Ladies and gentlemen, please be seated. The ceremony will begin with a citation of Doa. I would like to invite Al-Fadil, Ustaz Muhammad Amirul Hakim bin Saparuddin to lead us in the citation of Doa.
Assalamualaikum warahmatullahi wabarakatuh. Ila hadratil Mustafa Rasulullah sallallahu alaihi wasallam wa ala ashabil kiramil Fatihah. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin, arrahmanir rahim, maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim, siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin, hamdan hamidin, hamdan syakirin, hamdan yuwafi ni'amahu wa yukafi mazidah. Ya Rabbana lakal hamdu kama yanbaghi li jalali wajhika wa 'azimi sultanik. Allahumma salli wa sallim ala sayyidina Muhammad wa ala alihi wa sahbihi ajma'in. Allahumma anshurna syu'urul mahabbati bainana wa rabbit qulubana bil karamah wa ahsin akhlaqana bin nuri wal hidayah wa tsabbit qulubana bi kulli ri'ayah. Allahumma ya Rahmanu ya Rahim. Wahai Tuhan kami, segala puji dan syukur dipanjatkan kepada-Mu ya Allah, di atas segala rahmat dan nikmat yang telah Kau berikan kepada kami ya Allah. Kami bermohon agar Engkau berkatilah dan lancarkanlah majlis kami ini, majlis syarahan Perdana Siri 1 bagi tahun 2020. Jadikanlah majlis ini sebagai satu majlis yang diberkati dan diridai oleh-Mu ya Allah. Jauhilah majlis kami ini dari sebarang cacat cela serta perkara-perkara yang mengaibkan kami. Ya Allah, ya Dzal Jalali wal Ikram, dengan keberkatan majlis ini ya Allah, kami mohon taufik dan hidayah-Mu ya Allah. Kurniakanlah kesejahteraan, kebahagiaan dan keselamatan. Anugerahkanlah kepada kami kesihatan yang sempurna, akal yang cerdas, hati yang terang dan ingatan yang kuat untuk menerima ilmu dan pengetahuan serta bimbingan para guru kami yang kami kasihi. Ya Allah, perelokkan untuk kami agama kami yang menjadi penjaga urusan kami ya Allah. Perelokkan untuk kami dunia kami yang menjadi tempat hidup kami ya Allah. Perelokkan untuk kami akhirat kami yang menjadi tempat kembali kami. اللهم اجعل جمعنا هذا جمعا مرحوما وتفرقنا من بعده تفرقا معصوما ولا تجعل اللهم فينا ولا معنا ولا من يتبعنا شقيا ولا مطرودا ولا محروما ربنا عليك توكلنا وإليك نبنا وإليك المصير ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين تقبل الله منكم.
Thank you Ustaz Muhammad Amirul Hakim bin Saparudin. Assalamualaikum warahmatullahi taala wabarakatuh and salam sejahtera. Yang berbahagia Profesor Datuk Teknologis Dr. Wahid bin Razali, Vice Chancellor of University Tun Hussein on Malaysia. Yang berbahagia Profesor Teknologis Dr. Haji Badrul bin Haji Omar, the Keynote Speaker for the first UTHM's Lecture Series Program 2020. Yang berbahagia Profesor Dr. Ismail bin Abdul Rahman, Deputy Vice Chancellor Academic and International. Yang berusaha Associate Professor Dr. Shahruddin bin Mahzan, Layas Muhammad Zain, Dean of Faculty of Mechanical and Manufacturing Engineering, all UTHM senior officers, professors, head of offices, and students. Ladies and gentlemen, Alhamdulillah, all praises to Allah, as with His grace, we are all together here in the first UTHM Lecture Series program for this year. This program is exclusively organized by the Chancellery Office and Faculty of Mechanical and Manufacturing Engineering, UTHM. It is also aimed to provide a great opportunity for all to gather, learn and discuss the ideas and issues addressed in the lecture with the university community. Next, without further ado, I would like to invite Yang Berbahagia Professor Dr. Ismail bin Abdul Rahman, Deputy Vice Chancellor Academic and International, UTHM, to introduce our keynote speaker. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good morning. The Honorable Professor Dato T.S. Dr. Wahid Razali, Vice Chancellor of UTHM, Senior Officer, Professors, Head of Office, ladies and gentlemen. All praises are to Allah Subhanahu wa Ta'ala. Salawat and salam upon our beloved Prophet Muhammad sallallahu alaihi wasallam, his family, companions, faithful and honest followers. Firstly, I would like to express my gratitude for the opportunity of being here at the UTHM Premier Lecture Series 1 2020. I truly hope that today's event will provide not only knowledge to all of us, but also new ideas and vision, especially from the speaker's experience that he will share with us today. Therefore, without further ado, please allow me to introduce our speaker. Ladies and gentlemen, today we have Professor T.S. Dr. Badrul bin Omar of FKMP to share his field of expertise with us. A glance at his family background, Professor Badrul was born in Perlis on the 24th September 1958. His father was then a policeman, while his mother was a full-time housewife. Professor Badrul is married to Associate Professor Dr. Wan Aslinda Wan Muhammad from FPTV, whom they met while working at Polisas Kuantan. You may stand. They have been together since 1986 and blessed with 3 children and 3 grandchildren. Ladies and gentlemen, Professor Badrul education started at primary and secondary school in Perlis. He is one of the graduates from the first batch of MCE Malaysian Certificate of Education of Sekolah Menengah Sains Perlis. Due to his achievement in the MCE exam, he was awarded a federal scholarship by the Ministry of Education to pursue his studies at the United Kingdom. He obtained his GCE A-level at Bristol, England. He then continued his study. His education continued and was awarded Bachelor of Science and Honours in Mechanical Engineering from University of Leeds in 1982. Postgraduate Certificate of Education from the Malaysia Teachers College Penang in 1983. Then Masters of Science in Computer Aided Engineering from Liverpool John Moore University in 1989, and PhD in Mechanical Engineering Design from University of Leeds in 2008. His career started as a lecturer in mechanical engineering at several polytechnics in Malaysia since 1983, namely in Kuantan, Kota Baru, Port Dickson, and Shah Alam. Before joining UTHM, he worked as an assistant director at the Technical Education Department, Ministry of Education, Malaysia. He joined UTHM in 1999 until now. Ladies and gentlemen, Professor Badrul's research interests include design sustainability, engineering design methodologies, and design optimization, where he had acquired numerous grants and award at national and international innovation competition. With his keen interest in research, his publication so far includes more than 120 articles, journals, and conference proceedings, several book chapters, and books in multidisciplinary area. In terms of supervision, he has managed to graduate 5 PhD students and 11 master students, and 3 more PhD students ongoing. Ladies and gentlemen, without further delay, please join me in welcoming Professor Badrul to give his lecture entitled Novelty and Challenges in Sustainable Engineering Design. Wassalamualaikum warahmatullahi wabarakatuh.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي ولا حول ولا قوة إلا بالله العلي العظيم أما بعد بسم الله الرحمن الرحيم The Honorable Vice Chancellor Professor Dato' Wahid bin Razali, the Deputy Vice Chancellor, Professor Dr. Abdul Rahman, Ismail Abdul Rahman, sorry, all the deans, head of departments, colleagues, and my beloved students. Assalamu alaikum warahmatullahi wabarakatuh, and a very good morning. Alhamdulillah, we are gathered here today for me to be able to share with you some of my thoughts and reflections on this topic. Now, if I were to reflect back when Dr. Aminah called me a few weeks back to ask me to give this talk, I was thinking very hard on what kind of talk I want to deliver today. Actually, this kind of topic I've already delivered at several other venues, but I made some updates on the slides regarding the recent research that I've did on this topic. So I would like to share that with you later on, inshallah. Now, if you look at the topic today, sustainable engineering design. Now, if you look at the keyword here, engineering design, I've been involved in engineering design since my undergraduate degrees, okay, way back in 1982. And when I did my master's and later on my PhD, all my research interest has been in this area. even though it's not what we would say a mainstream research area, not quite a popular research area, but it is one area that is quite challenging in terms that it is an area that is included in the upstream activities of engineering rather than all the other research areas that are did in the downstream area. So when I was looking at this area of research, I was looking at how can we improve engineering design process and methods. So we can develop tools, we can develop approaches in order for us to be able to help designers, for them to be able to do better and better design. Okay, so that's why the topic of this lecture is thus sustainable engineering design, novelty and challenges. Now the item sustainability here is not included recently, but has been discussed in engineering design for a number of years already. Even though the word sustainable development came about in the late 1980s, but the talk about sustainability in design has come about much earlier than that, when they were talking about life cycle issues, when they were talking about product life cycle, when they were talking about circular economy and so on. All these are aspects that make sustainability a very important aspect in engineering design. Let us recap. Probably most of you will know about this already, but the outline of my talk today will contain this: sustainability in engineering, current practice. We will look at some aspect of early design phase. I think this is important because there are lacking in research in this area. I've mentioned the downstream area is very matured, but here there's still a lot of work need to be done in order for us to be able to do more work here. And then optimization in upstream design phase, the issue and challenges in this area. Current research, I will talk about some of the research that I did with my students here. And then sustainability for all, and then I will summarize inshallah later. Now, let's recap. I think a lot of speakers even at this venue has talked about this already. We have talked about sustainability. Even Prof Ismail also talked about this during his lecture, if I remember correctly, about sustainable in the construction industry. Okay, and sustainability is an issue that's very important now with the current event that's happening around us. I take one recent event that happened last year in Sungai Kim Kim, if you remember back. Those are because of issues of sustainability. And if you look at the most current issue, the COVID-19 pandemic also, I believe if we trace it back, it will all come back to how sustainable have we been doing our activities. Okay. Now, if we look at sustainability, I think this is the most appropriate definition that we can get. We have to remember that the world that we live in today now is a world that we are borrowing from our children and our grandchildren. We have to remember that. So we just cannot just look at our needs. We have to look at the needs of our children and also our grandchildren. So the meeting the society's present need without compromising the ability of the future generation to meet their own needs. So this was quoted from the Brundtland Commission in 1987. So it's still valid until today, I think, because this definition of sustainability will make us realize that we need to work more in order to ensure that our future generation will also be able to enjoy what we have been enjoying today at the very least. So humans are an integral part of the natural world and nature must be preserved. But if you look at sustainability, it's not just about the environmental impact issues that we are looking into. We are also concerned about the triple bottom line solution. That means to say that it must be also good for the environment. That's one thing. Okay. It must be good for the economy as well, and also good for the society. So the triple bottom line is the environment, the economics, and society must be looked at if you are going to talk about sustainability. So in order for us to claim that we have a sustainable development, we must look at all these three pillars, okay? And in terms of the economic aspect, we have need to look at how the business can be made to be more sustainable. The environmental impact, what impact does we have on the environment, our activities and our design. And the social aspect is how do we improve the social aspect in order for us to make it more sustainable. So in looking at this, the ideal solution would be that all three aspects are taken into concern when we are talking about sustainable development. Okay, yes, I agree that we are also part of the problem. Yes, we create many activities, we create many technology, but at the same time, the output from this technology will also harm the environment in some aspect. But we are also an integral part, an important part of the solution as well. We have come up with many technology that in a way that will contribute towards the sustainable development. Okay, see, these are some of the technology already developed and already in use that already is helping in this aspect. But we need to remember, engineers of the future need to think differently. Okay? Not only think, but design differently, because we just cannot keep on doing the same thing over and over again, because the same issues will crop up much later. So the traditional engineering design criteria focus more on function, cost and safety. This is the traditional thinking. So we have to realign our thinking, do some sort of adjustment so that we are looking at it from a sustainable engineering design criteria. So the above are important, yes. Function, cost, safety, yes, still very important. But apart from that, we must also look at the impact on the people, the society, and of course the impact on the planet in terms of environment. So these are some of the thinking that we are expecting our future engineers to be able to think about. Okay, so typical question for future engineers would be the type of material that we're going to use. Is it going to be recycled material or reusable material? The type of energy it will use. Are we looking at alternative energy rather than just relying on traditional energy source? How is it going to be powered? Okay, and how is it about the recyclability of the product at the end of its life? We just cannot think about a product just at the point of sales only. We have to think further about the service life and the maintenance life, and of course at the end of the life. And then what parts that contain toxic material that must be disposed of. So these are some basic questions that future engineers must be thinking of when they are designing any product. And especially so if you look at the example here, our household product or our consumer product, a very common one is the handset that we have here every day. In fact, our own handphone here, if you look at it, there are some toxic material involved, okay, in the production of this type of product. And we must be thinking of how are we going to be able to contain the toxic material or toxic metal that we are going to discard at the end of the life. Now, I took this example from NASA when they are doing their project, especially their Apollo project and other project as well, Apollo, Shuttle and future project. As you can see, the concern about sustainability and environmental requirement has been increasing steadily since the early part of the project. But as they introduced the Apollo and the Shuttle and other project as well, as you can see here, the amount of environmental requirement has increased quite significantly. So as you can see, the concern about environmental impact has already been taking place, okay, around the world. And this is one good example of the kind of activities that they have done in order for them to be able to ensure that all their activities will be sustainable. Now, this is, when we talk about sustainability, we cannot escape from the environment, the economics, and also the social aspect. But the current worldview, okay, in my own understanding now, if we look at it from many perspectives, you will see that it is a bit more skewed. That means to say that a lot of industry are more concerned about the economic aspect rather than the environmental effect and also the society effect. So this is the thinking that we have right now. So the concern is more on the economic aspect. So this has to change. So when we are talking about environmental concern, we see that the environment must take the central stage, and then we need to think about the society, whereby the infrastructure must be in place in order for us to be able to achieve this. And then only then that we can invent the economy, all the products that we going to produce. So this is the way that we should be thinking. First the environment, and then the society, and then the economy. Even though this might seem a bit more unrealistic at the moment, but we can, okay, always work together for us to be able to achieve this in terms of the kind of products that we can produce from our engineering design. So we have a critical engineering impact, critical sustainability impact in such a way that we really need to think about sustainability issues at the beginning of the design stage. Now, in any design process, you will see that the upstream process is quite lacking in terms of the thinking about sustainability, while the downstream area is very mature in that area. A lot of tools that has been developed previously and also currently, they are more towards the later end of design rather than the early part of design. So we have to remember that when we do any design, the impact of the design, the early impact of design is very important. You will see that during the early part of a design, you will see that 70 to 80% of the total project life cycle cost has already been committed at the early stage of design. So if you want to make any impact, we have to make the impact early rather than later. Right? This graph is very important. Okay? So in order for us to be able to do that, we have to give an early assessment of many aspects. Okay? Sustainability aspect, either economics, environment, or social, so that we can provide the assessment to cradle to grave as needed now. So the highest leverage is early in design. So that's why I've always been talking about this. in order for us to be able to impact, then the early part of design is very crucial. Now everybody is here is, I think, aware of the concepts or the stages in design. We have the conceptual design stage, we have the embodiment design stage, and then we have the detail before we go to production and so on. You will see that how we make the important decision at the early part of design will impact all the other subsequent stages. So it's very important, any assessment that we want to make at the early part of design is there. So what can we do about this? So some suggestion that has been put forward by many researchers about this aspect is how we choose the technology. Okay, technology is advancing at a very fast rate. I take one example, technology in materials, for example. We have a lot of hybrid materials now, composite material research being done, and all these are contributing towards the impact of the technology, the kind of material that we can use so that we can use it in our engineering design. Number two, the impact that we can have or what engineers can be doing about it is understanding the environment. This is crucial, and I think most engineering programs now are also emphasizing on this. Okay, the environmental aspect or the environmental impact that any engineering activity will do. And then lastly, appreciating the social challenges in making it happen. Because in order for us to make all this technology and environmental impact to be able to be accepted by the society, it has to be able to be accepted by the society first. Now, a huge challenge that we have is regarding materials and energy. So this is two main concerns that we have in order to drive sustainability in engineering design. Okay, so we need to be able to drive materials efficiency in a much better way. So I've talked about how research in material is ongoing, and I think this has a lot of impact in that area. We also have a lot of research being done in energy efficiency. We are looking at alternative energy, hybrid energy, and so on. So these are all very important aspects in research that is helping in our sustainable development. So what I'm trying to say here is we need to be able to choose the right engineering tools in order for us to be able to come up with sustainable product. So we just cannot expect our product to be able to have a high impact, but a lot of concern about its sustainability. So we have to place ourselves basically in the lower left corner as much as possible in order for us to be able to have this impact. And of course, this will take leadership. So basically what I'm trying to say here is sustainable development is not about doing things we are doing now, but doing them less bad, okay? It's about designing and producing products we need for a growing and prosperous society that are actually good. And this I quote from this commission also in 1989, and I think is still valid until today. And if you look at the current situation now, we see that we are no longer in a system that is very conventional system. We look at a system or an economy that is very complex. And as you can see, a lot of changes have come along the way. From a mechanistic world, we have a very complex systematic world. From Newtonian mechanics, we have chaos and complexity theories. From predictable outcome, we have uncertainty, patterns with disorder, arrogance over nature. We need to be humility within nature, and so on. So all these are the changes that we are seeing now. So we cannot expect to do the same thing now. So of course, when we are going to be able to implement this, the consultation or the engagement with the society and the industry is very important, very crucial. Okay, so we need not just to move away from just trust me, yes, an engineer that say trust me, but we are going to move towards technology or involvement that involve me. So these are the kind of thinking that we need to be able to engage. So of course the technical complexity will increase because of the advancement of technology, but at the same time we also need to ensure that the social complexity is also taken into account, because we live in a world where this is very diverse and it's a global world now. There is virtually no borders now. Okay, so because of that, the social complexity need to be also taken into account in order for us to be able to do this. And this will need new engineering skills. So rather than I talk about sustainable engineering design, I think I'm going to go on a larger global area. I want to talk about sustainable engineering, because this is the larger picture. When I talk about sustainable engineering design, it's just a small aspect of sustainable engineering. Yeah? So sustainable engineering is the process of using resource in a way that does not compromise the environment or deplete the material for future generations. So as you can see, they are taking the Brundtland definition and expanding a bit more in order for them to include sustainable engineering in this area. And because of this, we need to look at it from a multidisciplinary point of view rather than just fixed to certain discipline only. So sustainable engineering, we need to move from the traditional engineering thinking to sustainable engineering. First one is considering the object or process. And then now we need to think about the whole system. And previously we focused on technical issues. Now we need to also include not only technical but also non-technical issues as well, especially from the social and economic aspect. And then solve the immediate problem, but for now we are going to solve the problem but also solving the problem for the future. Then we consider the local content for the traditional thinking. Now we are talking about the global content. I think everybody is aware of this already. Okay. And then assume that others will deal with political, ethical, and societal issues. But now we have to engage all the experts, because this is an important aspect in social engineering as well. So the main theme here is to be able to generate a balanced solution to any engineering problem. So if we look at sustainable engineering, there are many aspects that we can contribute. I think us as engineers, we have a lot of opportunities for us to be able to contribute in any of these area, either in environmental, society, and economy. And these are some of the main issues that we can contribute towards in our research. So in order for us to be able to think of sustainability in our engineering activity, we need to think of sustainability as a hierarchy like this. So that means to say that first we need to think of the principle of sustainability as the overlying principle, and then we have sustainable design, then sustainable engineering, and this will lead to technologies that will also produce processes and product that will be able to support this sustainable lifestyle that we require. So these are some of the engineering challenges. There are future engineering challenges that we are embarking upon, and these are some of the, I think most of it has already been worked upon, and as you can see, most of them are related to IR 4.0, okay, most of them. So as you can see, these are also some of the challenges that we can face and also introduce in our research in order for us to be more sustainable. Lifecycle management is also a very important aspect. When we talk about a product, we not only talk about a product from inception to sales, but now we need to talk about the product from inception until disposal. Okay, so lifecycle management, product lifecycle management has become a very important aspect in today's product. Of course, we have a lifecycle assessment tool that can help us to be able to do all this lifecycle management. And I think this has greatly helped many companies and many products in order for them to assess that their product is sustainable. Okay. And another aspect that sustainability has demanded is that we also need to think about material flow accounting. Okay, this is probably one aspect those in material research can look into. That means to say that how can we be able to control the toxic or eco-toxic substances that we introduce into our product and system. And also nutrients such as nitrogen and phosphate, how will they influence our decision in our research? And one aspect about aluminum, how is it going to be recycled, reused, and this need to be improved in order for us to have this material flow accounting taken into account. And then we can also, from the social aspect, probably, when we look at the more on the consumerism, okay, we can look at the function-based approach, whereby human needs to be able to meet by product and service that are aimed at specific function, such as food, shelter, and mobility. So here we are basically focusing on some basic function approach so that we can be able to satisfy these needs. Another aspect is about eco-design. So when we are going to do any eco-design, probably one aspect or one tool that we can use in order for us to ensure that our design is termed as eco-design is this matrix. So how can we categorize our product or system? In which category are they? So basically, the best one is the one highlighted in blue there in category 1. So we try to be able to design our product in that manner. So these are some examples of eco-design that has been done in the West. This is one humidity catches. Okay. So because humidity is probably a problem there, so they develop what we call humidity catches. Okay. And of course, eco-design number 2, example number 2. Now we have clothes from recycled material. I think this is becoming more and more common now. Okay. And one aspect that we can also look into in order for us to support this sustainable engineering design is supply chain management. So how are we going to ensure that our supply chain can be made to be green? Okay. Now, I've talked about sustainable engineering design at length. Now I'm going to talk about some of the research that my students and I have been doing in order to support this thinking. So before I do that, let's look at one typical design model. So this is the Pal and Bice model. It's not a new model. It came about in 1977, but it is one of the most popular models used in research and also in industry, especially in Germany. Okay, and as you can see, it's divided into several parts. The upper part is called the clarification of needs, and then we have the conceptual design, and then we have the embodiment, and then we have the detailed design. So basically what I'm trying to say here that the downstream design tools are mostly matured, okay? The ones more concerned towards the detailed design. When we look at manufacturing, we look at materials, we look at production processes, all those are centered around the later part of the design model. But when we go up to the upstream design activities, we see that there are still lacking of tools that can help support sustainability in that area. I've said this in many forums that I've said that engineering design is the core activity of any engineering activity, even though some of my colleagues, especially in materials and manufacturing, might not agree. Okay, they would say that manufacturing is the core, where design is just a simple part of it. But I beg to differ. I would say that without design, okay, without engineering design, there won't be any manufacturing in the first place, and there won't be any need for any materials, new materials especially. Okay, let's look at one of the research that I did. I came up, my students and I came up with this research in supply chain sustainability, okay, SCS. Okay, we developed a framework whereby we are trying to take supply chain thinking at the early part of design. Okay, what we did is we surveyed about, I think if I'm not mistaken, 300 companies. Okay, 300 companies, and we tried to gather what kind of sustainable activities that they did in their supply chain. So from that database, we have some analysis done, and we came up with this framework. So this framework has been tested at on 2 products, and currently is being tested at 1 company in order to ensure that all the supply chain thinking can be brought to the early part of design. Even though for the product we can say that this was successful, but the validation at the industry is still pending. So this is one of the our contribution toward supply chain sustainability in this area. Another one is ASPD, Axiomatic Sustainable Product Development. This was developed a number of years ago, ASPD. So whereby we look at 3 aspects, manufacturing solutions, we look at design for EOL, end of life, and then we look at green supplier selection. So in order for us to be able to cater for all these 3 aspects, we use one approach, which is axiomatic design, which is quite a popular techniques in design research. So we came out with this ASPD, and we tested it in Dyson actually, in Johor Bahru, on 3 products actually. And the outcome of that was quite successful in terms of the sales that they have generated because of the use of this approach. So that was one of the success story of this research. So this is also contributing towards sustainability in engineering design. And incidentally, this research has also gathered a lot of interest worldwide. So far, I think the paper that we have produced for this research has been cited about more than 50 times already. Alhamdulillah. And then this is the earlier part. In 2012, we did this. Okay, we did design evaluation. This is more specific towards design methodology. How do we evaluate design according to certain criteria? And we include some sustainable issues in this evaluation. And this is the framework that we use. And in this case, we use this rough gray analysis in order for us to be able to evaluate according to the specific needs. So the rough gray will come at the later end, but we need to collect the data from various sources in order for us to be able to do this rough gray analysis. This was tested in Pahang at 2 companies. Alhamdulillah, even though the success story is not as good as the second one, but it does make an impact on the product they have been able to design using this approach. Alhamdulillah. And then this is the more recent one that my students and I is doing. I think he's here in here. We are looking more into biomimetic design or bio-inspired design. So that means to say that we are going to look at what nature, or I would like to call it as what has God provided for us. And then what can we learn from those nature's way of doing things, and then we can implement that into our own engineering product. So we came up with this bio pattern framework, and there are 2. Okay, problem-driven bio pattern framework. So here we are trying to bridge the gap between biology and engineering. So we came up with this framework whereby we have did a lot of search in order for us to come up with a database that will give us some indication or novelty when we are trying to find solution to engineering problem. And so far we have tested this. There are 2. First is the problem driven, and the second one is the solution driven bio pattern framework. So we have tested this on 2 companies so far, and alhamdulillah they have come up with some very specific idea on how to overcome those problems. Okay, I think when we go into biomimetic design, maybe I can relate to you one story about how biomimetic design has been quite successful around the world. If you look at the introduction of Velcro, for example, Velcro, the one that we use on our clothes, on our shoes, when the original inventor of Velcro, he came up with this idea when he was on a hunting trip with his dog. He was an engineer, a Swiss engineer. So when he was doing his hunting, you will see that a lot of his dog and also his trousers will be filled with all these weeds. And when he investigated them further, you see that when he put it under a microscope, they have what we call a loop and hook structure. Okay, loop and hook structure, and they are very microscopic in nature. And because of that, he invented the loop and hook adhesive, and it has become a worldwide phenomenon. And now he's a billionaire, I think, if I'm not mistaken. Of course, his patent was taken over by the Velcro company, and now he's very well off. So this is one example of biomimetic design that we can see. Another one that I can share with you is about when the last government, not the PH, the BN before that, introduced the high-speed rail, the project for the high-speed rail. We were interested in how can they achieve the high-speed rail with the nose shape at the front and the rear of the railway, of the coaches. So we did some investigation in that area. My student did investigation in that area and found that there are very much similarity between the shape of the bogie, not the bogie, the coach, to some nature's inspired shape. For example, if you look at the Shinkansen in Japan, it is very much inspired by the dolphin shaped nose, dolphin. And if you look at the more modern high-speed rail, you will see that most of them are inspired by the kingfisher's shape of the bill. So a kingfisher, they will be able to dive from a very high altitude right into the water to be able to catch their food. So at that speed, they are considered the fastest animal in terms of speed. So when we investigated that, we see that the shape of the beak, okay, is very much similar to what they have come up with for the high-speed rail shape for the train. So those are some interesting biomimetic design that we have encountered, and we try to inculcate them into this research. And alhamdulillah, I think we are still testing it. So far, we have tested it on 2 case studies, and we have also tested it on some engineering design projects here in UTHM, and we see that it gives some contribution in terms of the novelty that we can come up with engineering solutions. So those are the 4 research areas I want to share with you today. But basically, when we do any design research, we will face many challenges, of course. Okay, but I think this is also true for any design or any research. So, but specific to design research, the challenges are the communication between industry or the collaboration between the researcher and the industry. I think this is a common problem. So somehow we must engage the industry players and the stakeholders in order for us to be able to convince them that what we are doing is worthwhile. When we talk to them, they are only concerned about the economic aspect. So we have to convince them of other aspects as well, okay, before we can try to prove our point with them. And then challenging data collection. Design research is a bit different. It is more qualitative rather than quantitative. So we have to rely more on case studies, in order to prove our point. And then validation issues. Okay, this is also another big challenge that we have. Most industries are very reluctant to try out new approaches in design. Most. Okay, so what we can do is try to engage them over a long period of time so that they have the trust in us. And because of that, we can be able to try out our approaches in their own system. Effectiveness of new methods is also being questioned because the reluctance on their part is probably because due to how effective can this method be used. And then, of course, the issues of commercialization. I think this is also very common in any research. And then acceptance by industry and stakeholders. So those are some of the main issues faced. Basically, it is more about how we engage the industry and stakeholders in order for them to be able to accept our work. So in order for us to have a sustainable engineering, these are some of the discipline that we can look into. Okay, we can look at waste management system, we can look at waste generation, we can look at household consumption patterns, and of course we can look at production patterns as well. Okay, so on our part as a consumer, probably we can look at how we can contribute towards household consumption patterns, right? And if you are in the production team, then the production patterns must also be looked into in order for us to be able to claim as a sustainable technology. And waste management system is also a very important aspect, whereby we need to look at the economic tools there, the regulatory tools, and the technical innovation needed for us to be able to contribute here. So I would like to end my lecture. I think it's 1 hour. okay, by saying that we are all part of the continuum of humanity and life. We will have lived our life, our brief span, and either help or hurt the continuum and the earth that sustain all life. It is that simple. Which will it be? So I quote this from Ray Anderson in 2008. But I think the best quote of all is from this Apple computer executive. He said that the best way to predict the future is to invent it. And this can only be done by sustainable engineering design. So with that, I'd like to thank you for your kind attention to hearing to my thoughts and reflection on this matter. I've been doing research in this area for about more than 20 years now. And these are some of my collected thoughts and that I have gathered along the way. So I hope this will give you some thoughts and ideas on how to go about on your own research in your own area. I believe we all can contribute towards sustainable design in that aspect. So with that, thank you very much. And now we're open for Q&A if they have any. So selalunya bila Q&A ni saya selalu suka quote saya punya ustaz lah. Kalau nak balik cepat jangan tanya soalan gitu. Tu ustaz saya lah je. Saya quote je. Any questions? Ustaz sama, okey. Ustaz tu kuat popular lah kat Batu Pahat ni. Yes, Dr. Kamarul. In light of what was happening, I think the past few years, there were a lot of import of plastic materials, all those containers that were imported here so that we can use the recycling center here. But if you look at the data being gathered, if for one container that was imported here, only about less than 30% can be recycled. The rest has to be discarded. And the best way for them to discard is to burn them. So, of course, this is not a sustainable, viable solution. So that's why I think the previous Department of Environment, they are doing a lot of good things as well. They are sending back all these containers to their source country so that they can deal with that themselves. So this is one way from the law and regulation. But from our aspect, I think we have to also look at two areas. One, from the consumer attitude. Okay, so we have to rely less and less on this non-biodegradable material. Okay, because if you discard plastic, for example, a plastic paper, it will last until hundreds of years in the ground. And because of that, we need to be able to look at the design from the aspect of maybe biodegradable plastics. Even though this is advancing very fast, okay, I believe, but still there's a lot of things that we need to do because if we compare between the economic aspect of biodegradable and non-biodegradable plastic, we still have a long way to catch up. So, and the second aspect I was thinking about is the industry themselves. Okay, the industry should look into ways on how to replace all this non-biodegradable material with other material. And of course, research into this area is ongoing. And I think this will provide the technology for us to be able to provide this solution as well, inshallah. Okay, any other questions? Yes.
I'm just wondering, in your opinion, what is the best design that reflects the sustainability when it comes to those three concepts that you showed, in economy, environment, and also social? I just want to know in your opinion.
Now, if you want to take a certain example to show how this product can impact all three aspects of sustainability, I can't think of any offhand, but I think the nearest one to it is when we look at most consumer products now. Okay, if you look at most consumer products now, for example, your handphone and so on, they has been designed according to sustainability requirement. Okay, because if you take apart any consumer product, you will see that almost every part of it can be recycled, and almost every part of it has been designed according to some sustainable requirement, either from a social, economic, or environmental impact. I think the best example is in your hand already, your handphone. The modern one, of course, not the old, the brick type handphone that we had previously. Okay, that's probably one example I can give you. Yeah, Dr. Hassan?
Saya ada satu soalan. Boleh. Okey, sebab sekarang ni orang kata penggunaan straw tu macam bagi impact yang besar. So untuk kelestarian tarian tu dia bukan kepada yang biodegradable ataupun kepada kertas sekarang. So sebenarnya apa yang dia punya impact tu kepada sustainable ataupun yang produk lain lagi banyak impact kepada itu.
Straw ni, this straw, the issue is regarding it is a one-off use, okay, and it's being produced at billions of units, okay, per year, billions. I'm not talking about millions, billions of units per year in every country, almost every country, producing this straw. So can you imagine after one use, you throw it away, okay, the impact on the environment, and we have. Most researchers, they have encountered either straw, whole straw, or bits of the straw in many, many areas. One of them is in marine life. Okay, and this has had big impact on the sustainability of the marine life. So because of that, I don't remember the exact figure because I haven't been following this research for a while now, but the impact has been such in a way that they have come up with means in order for us to reduce our reliance on this straw for our everyday use. So now they have come up with better and better technology, alhamdulillah, either by using metal straw, okay, so you can use it over and over again, or you can use natural straw. I think they have developed some natural straw as well, okay, and naturally made straw. I think there was some work being done in Thailand whereby they have these weeds. They are shaped like a straw that can be used. Again, that is a very natural straw. And of course, we can also, I think, look at other materials that we can use in order to develop this straw. I believe this straw is still an essential part of our everyday life, but we need to look at other alternative material rather than relying on plastic. Yes, paper is one choice, but again, it is also a one-time use. So we have to look at the product either from the aspect of multi-use or other types of material. That's my opinion on it.
So we know glass with the straw, and then the straw is the
That is one aspect that we can look into, yes. Okay, we have the glass and we can put the straw together. So that's the aspect of design. Okay. That would be one novelty that we can use. Okay, thank you very much for that idea. Any other questions? Okay, if there's no other questions, so thank you very much for the interesting Q&A session. Maybe my response will give you, some spark in your mind in order for you to come up with other ideas, either in your research or everyday life. So I hope that, inshallah, you will have a successful career here in UTHM for all the academics, and a very successful program for all the students here. And all the best to you. Dan Assalamualaikum warahmatullahi wabarakatuh. Saya duduk Tak apa. Kawan-kawan lama tak apa.
Thank you very much for the inspiring and informative speech. It was very interesting to know about novelty and challenges in sustainable engineering design. Ladies and gentlemen, we would like to express our gratitude to the speaker for sharing his valuable knowledge and experience with us. We would like to invite Yang Berbahagia Professor Datuk Technologist Dr. Wahid bin Razali, Vice Chancellor of UTHM, accompanied by Professor Dr. Ismail bin Abdul Rahman, Deputy Vice Chancellor Academic and International, to present the Certificate of Appreciation to the speaker. Yang Berbahagia Professor Technologist Dr. Badrul bin Omar. Thank you, Dato. We would like to thank all the invited guests for taking the time to attend this ceremony. This is the end of the lecture series program. On behalf of our organizers, we apologize for any shortcomings throughout the ceremony. Till we meet again in the next lecture series. And to inform to you guys, before you leave, the attendance machine are provided on the right side for the staff and on the left side for the students. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.